Good afternoon. Welcome to Blackhat. You are currently in the mobile track. This is Don't Stand So Close to Me. I'd like to introduce Charlie Miller from Accuvent Labs.
Thanks. So thanks for having me. So yeah, I'm going to talk to you. Oh, do I have to flip this? It'd be nice if you could see my slides. There you go. Okay, so I'm here to talk to you today about NFC and the dangers of having NFC chips, if there are any, on your phone. Okay, so who am I? It was a great introduction, but I could talk about me all day. So the first one to write iPhone Android exploit, one pwn known, got this cool jacket, 4 years. Only got one jacket though. Wrote some books, have some letters I can put after my name. However, I'm not a member of the iOS developer program. So what am I here to talk about today? So first I'll start off with saying like why I looked at NFC, and it's because of that guy right there. Yeah, that guy. And then talk about some very basic NFC stuff, and then I'll explain how I wrote a fuzzer that you can fuzz the NFC stack on phones with, and then I'll look at the apps beyond the low-level code, so like what apps deal with NFC even after you've given them the data. And then I'll have some like hopefully cool demos and videos and stuff for you at the end. So basically the talk I spent like 9 months on this, so in the fall there weren't that many devices around. So the only ones that really had Android at the time were Nexus S and Nokia N9 that I had access to. So those are the phones I looked at initially, and I got a Galaxy Nexus later. Okay, so why NFC? Well, Moxie told me that it would be easy to find bugs in NFC. He was wrong there, but at least he got me thinking about it. And so like NFC is actually like kind of a cool technology. So for one thing, you know, John Evans says that iPhone's going to have it, and I like iPhone, so I want to know about that. All Nokia phones pretty soon will have it. Samsung, a lot of Samsung phones, Android phones have it, and supposedly Windows Phone 8 will have it. A lot of their devices. So anyway, there's going to be a lot of devices coming out with this technology, and so it's nice to know whether there's going to be security problems associated with that. And the other thing is, I cut my hacking teeth in the late 90s, early 2000s, and back then everything was server side. So HTTP exploit or SSH server exploit, and for me like browser exploits, it's like but then you got to get the guy to go to your website. It's sort of painful. So NFC is kind of cool, I think, because you don't have to necessarily have the user do anything. And then, of course, the other reason I was sort of interested in it is it's hard. I like hard stuff. Okay, so like I said, my motivation in this talk is to see whether you can break into a phone with NFC. There's lots of other topics, NFC topics, out there. So, like, is our payment system secure? Can you brute force, the Google Wallet PIN? Can you get free, parking? Can you get free gym memberships? Can you, get free snacks? So these are all like really cool topics and interesting, but that's not what my talk's about. So my talk is about, the attack surface that having these phones introduces. Okay, so I didn't do any of that like fun stuff, but I did at least scan the Blackhat badges to see what was on them. So this is a couple badges that I scanned. You can see the data on them, and by the end you'll understand what some of that data means at least. But it's not anything too exciting. At least I went out last night and had fun instead of trying to reverse engineer those cards. Okay, so who's done similar work than me on this particular topic of seeing whether you can this introduces attack surface? Well, Kyle Molnar a couple years ago gave a talk where he did some fuzzing of the NFC stack, but back then he did it really manually. It was like write a tag, present the tag, write a tag, present the tag, and so. After probably like a couple hours of that, he got bored. So I wanted to sort of automate that. And then at SummerCon, he actually introduced a way you could simulate NFC traffic by doing memory injection in Android. So with that, you could fuzz as well, although I don't know if he's actually done the fuzzing. The closest work to this was by a couple academic people who looked at the Nokia 6212 and they saw whether you could break into the phone basically. And some of the results I have for the N9 are pretty similar since they're both Nokia phones. And then like a month ago, Dan Rosenberg found some vulnerabilities in the Linux kernel NFC stack. Right now that code's not being used. It's for hardware that's not available yet. But still, it just shows that there's potential bugs in the NFC stacks. Okay, so that's the motivation. I really wanted to write tools that would help people test NFC implementations because right now there really aren't any. And if I happen to find some bugs on the way, that's really cool too. So let's talk about NFC. So NFC is basically based on RFID. It runs at 13.56 megahertz, at least initially. There's some other frequencies used along the way. It uses the same standards as RFID. The thing that makes it different than RFID mostly is that it's designed to be very close proximity. So the specifications say like 10 centimeters sometimes. I've never seen that. The more realistic operating range is like a few centimeters. And for that reason, you see a lot of design decisions like we don't need encryption because no one can get that close and stuff. Some people have said they can read it across the room with like big, mega antennas and stuff, but that's not. I didn't do any of that. And then the data rates are, quite slow, so you wouldn't want to transfer a ton of data with NFC, even if you could. So here's a couple of videos. I don't know if you can see them very well, just to show you like in practice how close you can be. So I have a NFC hotel card key. That's what that white thing is, and it's in my wallet in my pocket, and well, not really mine, on a simulated person, and so I can read it. So basically, it can read like that, and then over here in this little clip, you can see that's about how close you got to be. So you don't have to touch, but you're definitely going to have to be pretty close to that. So when you think about like what kind of attacks could you do? Well, you could on a crowded subway or something, you could conceivably get really close to a phone, or like right by someone's pants pocket or something. I don't know, but like a more realistic attack probably is if replacing an NFC reader that you're using to pay for a cab or something with a malicious one, or sort of the equivalent of card skimming. You put another NFC device, or some NFC tags are just like stickers. So you just stick a sticker somewhere, or you replace an NFC antenna that's on a movie poster with yours or something like that. So there's lots of ways you could conceivably do it. So let's see how you would do it in practice. So is Todd Manning in the audience? Todd Manning, are you here? Oh, right there. Okay, so Todd Manning was a part of an experiment I was running, and he didn't know that until right now, to see whether I could read his hotel card key without him knowing it. So let's see if I could. So and Josh here was our crack film technician. So I'm the guy in the green, and Todd's in the checkered shirt. So I'm going to subtly try to read the tag right now out of his pants pocket. Let's see. He was never the wiser. I heard I could turn the volume. You can hear our idle chatter while this is going on. And I do have to say, though, not everyone could pull this off. I am a trained NSA agent. So here we are in the parking lot, and trying to, the moving target. So the elevator was easy, but the moving target's a little harder. So I have to admit, though, I never actually read his card key, and then when I followed him back to his room that night, I found out why. He went to get in his room, and his key was in his front pocket. But I think it would have worked had he had it in his back pocket, like me and J-Duck here had it. So, oh well. That was my foray into real attacks. All right, so that was a card key. So card keys are kind of always on. When is NFC enabled on your actual device? And so basically, it's on whenever your phone is awake. So like when your phone goes to sleep and the screen's black, it's not on. And when the screen's on, it's on. Some exceptions to that is once Ice Cream Sandwich came out in Android, if you have a passcode on your phone, the NFC chip is only on when the passcode has been entered, so when your phone's unlocked. For the Nokia N9, which is the other phone I looked at, NFC is on then, but it sort of behaves differently. But if you had a low-level bug, you could get to it. If you had one of these high-level bugs I'll talk about later, you can't get to those. So basically, if the phone's unlocked, then it's definitely available. And then what if you're... So imagine you have your friend and you want to own their phone because that's what friends do. And their phone is asleep in their back pocket, and you want to wake it up. Well, you can wake it up. It's easy enough, right? So here's an NFC tag. The phone's asleep, so the NFC tag doesn't work. Now I'll just, I know my friend's phone number, so I'll just send him a text message. So send him a text message, and then it wakes up the phone, and now the NFC is enabled. So you're walking along, send them a text message, pop them on the butt, and you own their phone. If you have bugs, which we haven't talked about yet. So you've at least been able to interact with their NFC chip. Okay, so there's basically two ways that NFC works. There's passive and active. So passive is what I've been showing you. So when the new iPhone with NFC comes out, you would just be like tag phone. So the tags are real simple. They're just like this one's just a sticker, right? It's just a sticker with like an antenna basically. And so the tags, they don't need power, they don't need batteries or anything like that. So they can be very small. And all the power is supplied by the reading device, in this case a phone. Active communication is a little different. So there's two actual phones or two active devices that communicate back and forth. And so that's basically the two modes that you'll see for NFC. So there's a lot of specifications for NFC, and I spent a lot of time reading a lot of these. And we'll go through sort of the important ones. And I should say the way the talks are arranged is you learn about NFC because you have to understand where there would be bugs and what the bugs are and stuff later. So bear with me through this part, especially if you know NFC. So basically it's like the low level stuff is on the bottom and the high level stuff is on top. So we'll start at the low level and talk about that. So at the low levels, it's basically radio waves going back and forth either between the passive device and the active device or two active devices. This is an FFT plot I took of a phone talking to a tag, and you can see it's at 13.56 megahertz. Not that big a deal. It's very slow, like I said, 106 kilobits. And then if you want to at this level, basically you're seeing waveforms. And so this is a waveform I captured using a USRP. And you can see basically the way it works is whenever the waveform dips below a certain threshold, then you get a 0 bit. And whenever it's above it, you get 1 bit. So you can see, you can't see real little, there's some ones here, but it's the same thing I wrote here. And then, so then you get this stream of line crossings. And then there's decoding. In this case, it's this Manchester decoding. It decodes into an actual bit stream. In this case, these bits. And then you can decode that into actual hex. And in this case, this waveform corresponds to this sends rec, which we'll talk about in a minute. So this is like the wake up for NFC. So it's kind of hard, right? I don't like to do that. I like IDA Pro and stuff. So I stayed away from the radio waves. The next level up is like initialization, anti-collision, activation, stuff like that. So basically, this is like how devices, when they learn that there's another device in their radio, within their, within range, how to start up the communication, figure out what's going on for higher levels. But there's basically not much going on here, and I actually didn't fuzz this level. I could have, but there's so little data, as you'll see, that it didn't seem worth it for the trouble. All right, now we start to get into more of the meat of the protocols. So up to this point, there's only been like 2 or 3 ways that they could communicate. But now you'll see there's like a whole lot of ways that NFC works. So there's lots of different chips and cards and ways that peers can communicate. So this is I don't even know what this one is, but there's ultralight cards and these topaz cards, and so there's lots of different kinds of tags that you can use, and they all communicate a little differently. Then at the bottom is the protocol you typically see for peer-to-peer. So let's dig into a couple of those that I actually look at in more detail later. So one is the one you'll see for type 2, also called micro ultralight. So in here, basically, the command set is what the phone can do can ask the tag, so it can basically read or write or decide where it wants to do. And the type of data that the tag can send back is represented in this diagram. So the first few bytes are things like a serial number basically. And then you get this thing called a capability container, which contains information like version number, amount of data to expect, stuff like that. And then the actual data that it's trying to transfer is, starts there where it says data. So that's what you see for an ultralight cards contain this kind of information. And then another kind of card that it turns out later that I can fuzz is this type 4 card. Here it's a little different. So basically the card contains sort of a file system. And what you do is you select I'll talk about it in a second, but you select first the capability container file, and you can read it, and it again has stuff like version information and size and stuff. But this one also tells you where to find, the file that contains the data. So then you can the device can then ask the tag, hey, then give me this file, right? So the typical flow of this thing is like, for this type 4 is like, okay, give me, I want to talk to you, okay, and then it's like, okay, I want to select the capability container file, okay, I want to read from the capability container file, okay, now I want to select the NDEF file. NDEF is the high-level data we'll talk about in a second. It's like, okay, now I want to read the NDEF data. So that's how, so you can imagine a lot of interactions going back and forth between the tag and the device. Is there some water? All right, so next up is peer-to-peer communication. So before it was just like a tag reading to, a phone reading from a tag. Now it's like two phones talking to each other. So there's data that goes back and forth. So there's lots of different types of packets that you can have. Packets, PDUs they call them. But the ones that are bold are the ones that you'll actually see if you're pretending to be a device. So this is sort of the data flow you'll see for this. So the first one sends a connect with some parameters about like how it wants to connect. The next one sends a CC, which means connection complete. Then the first guy sends an I1, which stands for information. Then the target responds with either more information or says acknowledging that it received the information. And then this goes back and forth as long as you want until one side disconnects. It's pretty simple. And then on top of LLCP, there's this higher level protocol because LLCP actually connects to what's called a transport endpoint. And from my experience, I've only seen two endpoints. One is NPP for NDEF push protocol, and this is what you see a lot on Android. And the other one is SNMP, SNEP. And that one is basically everything else besides Android, but in particular the Nokia phones had this one. So you connect to a service endpoint and then you send your data back and forth and everything's great. Okay, so we've done everything below that. Now we're up to the top level. So the actual data that's been transferred through all this communication back and forth. So the format of the application data is called NDEF, NFC Data Exchange Format. And it's some binary format. It's like type link value kind of stuff. And then there's different specifications for the types of data that can be inside of the NDEF message. So if you're like me and you read all these specs and you're like, oh God, what are they talking about? Like I need to see the data. So I'll show you guys a capture of a phone talking to a MIFARE ultralight chip. Actually, an NFC reader talking to a MIFARE ultralight chip. And I captured it using this Proxmark device. All right, so this is what the data looks like. Below or above the dotted line is the low-level initialization stuff, and then below the line is the Type 2 specific protocols. So it basically starts out like up here. So this is that sends rec I mentioned earlier. So it says wake up, and then this guy says, okay, I have 7 bytes in my serial number. And then this guy says, okay, send them to me. And then he says, okay, I can't send you 7, but I'll send you these 3. And then this guy says, okay, I got these 3. And then this guy says, good. And then he says, send me the rest. And then he says, okay, here's the rest. And then he says, this is what I got. And he says, good. So that's basically it. It's very simple. The only thing that I left out was in these communications is also actually communicating that, okay, and also I'm a type 2 tag. So when we get to the part where we use the higher level protocols, make sure you talk to me in type 2. So then when they get down here, and he starts talking type 2, the NFC reader. So he reads some data from the 8th column down in that chart I showed you. I don't know why. And then this is the data that the card sends back. Then he reads the 3rd column, which contained like the capability container and stuff. And so he reads that. And then he reads the 4th one down, and then he starts to get the actual data. So now you can start to imagine like how you would fuzz this, right? So like there's lots of, so I ignored this because there didn't seem like there was anything there, and it was hard. But down here you start to see like lots of data and binary data, and like that always makes my mouth water. Okay, so I pulled the data part of this message out to break it out even further so you can see what NDEF data looks like. And this is the NDEF data for that message. And so again, it's just like The first byte is, it says, hey, I'm an NDEF message, and then he says how long he is, and then he says he's a message. So MB is message begin, message end, which means message begin, message end. So it means it's complete. There's not, you don't have like a bunch of messages. And short record, which means the length is going to be 1 byte instead of 4, and so on. So then you get type and blah, 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 blah. And so there's basically specifications for each of these. So this is a type T for text, and so there's a specification that tells you how to read that. So it's like, okay, it's English, and it says, you know, sub ultralight or whatever. And then and there's a terminator. So this is basically what the data looks like that's going to, whenever you touch a tag to a phone, what's going back and forth. All right. Oh, and then here is the NF data that's on your badge. I just broke it out a little bit. So it's similar to the other one because it's NDEF. So again, you get a message, you get a link that's much bigger. This time it's a message begin, it's not a message end, so there was more data coming. I didn't copy it all. You get a type link. The type is pbcard.net B card. I don't know what that is. But it's a special type that's not defined in the specification, so it's like proprietary, right? And then there's data, some proprietary data. I don't know what it is. You could figure it out, and it's probably got like all our social security numbers and stuff. Okay, so now you're experts in NFC communication. So you have to think back and say, like, you know, where might there be bugs? Like, where should I focus? So let's look at one of the two operating systems I looked at to see what, you know, where the bugs might be. So starting on the left, you're in the kernel, right? In the kernel, there's a driver to talk to the actual hardware, the NFC hardware. And then in user land, there's a service, an NFC service, and that's what deals with all the NFC data that comes in. In Android, the service is written in Java. But it does contain a couple of native code libraries where you can imagine there being some bugs. And then once the service has the data, it passes it on to whichever application is intended to receive that data. The application that you usually see in Android is called tags. And again, this is some Java application. So, you know, from a tagger's perspective, there's a little bit of native code, a lot of Java, so, you know, maybe not so exciting. The equivalent picture in Migo, which is what the Nokia N9 runs, is like this. So it's basically the same. So you've got kernel, a driver, a service, and then, you know, applications that deal with the data once the service is done with it. The biggest difference from an attacker's perspective is everything is native code here. So the service is written in, you know, C or something, and it has a bunch of libraries, native code libraries, and then the application which is called connection dialogues, it's also written in some native code. And so you can imagine like memory corruption bugs sort of all over the system here. So at this point, you're just like, okay, so there could be bugs in like the way you parse NFC, and then there also could be bugs in the applications that deal with the NFC data once you get it. So we need to like check out both of those places. So to do the low-level, the inspection of low-level NFC parsing code, I thought it was like, well, I like the fuzz, so let's see if we can write a fuzzer to do this. So to fuzz NFC, basically 3 steps. First one is test case generation, so, you know, write invalid NDEFs or invalid, you know, capability containers or something like that. And then the hard part for NFC is then getting that onto a phone. So you know, it's like reading a tag. You have to, you know, make the phone think it's reading a tag. And of course, you know, phones are designed so that reading a tag means you take a tag, you take a phone, you put them together, and then you separate them, right? And unless like I have like a ton of interns, like that's gonna be hard. So you have to figure out some way to automate that. And then the final step, of course, is monitoring for crashes. So how did I do test case generation? And I should say at the end of the slide, I'm going to give you a URL where you can download all my fuzzers and all that stuff. So all this stuff I'm talking about, you can download today if you want, because I want you guys to find bugs in NFC stacks. So so I did a couple approaches. First, you know, my infamous, you know, Charlie Miller fuzzer that is like the dumbest fuzzer on earth. So I implemented that, of course. So you just take valid data, you flip bits, add bits, that sort of stuff. And so you can see like the types of valid data I started with are like, you know, information PDUs, capability containers, NDEFs, and stuff like that. And so I generated a bunch of test cases that way. And then I also went the extra mile for this research to generate some smart fuzzing. So I used Solid to generate NDEFs that, you know, are valid but long and stuff like that. So then you have to ask, how the heck are you going to get these? So generating test cases is easy. The hard part is getting this to the phone. like I said before, Colin did this sort of by hand once, but I want to know like how else can I do it so that I don't have to like build a Lego robot or something. So the first thing I thought to try was, well, I'll just get an NFC card reader and then see what to do. But it turns out there's lots of readers out there, and they all kind of claim that they do this, but none of them really seem to. And then there's lots of software to run the hardware, and you have to figure out which combinations work. And for a long time, I couldn't find a combination that worked. One way you could think about it is like, well, I'll just pretend, I'll do everything from scratch. So, from the radio level up, I'll just emulate everything. I'll pretend to be an NFC tag because I can do radio. So I tried that with this USRP. And I wrote all this code to do it, and you have all these crazy waveforms like this you have to decode and figure out what it is, and then send them the next message back. And it's really hard. So, and then even if you're smart enough to do that, which I don't think I was, then what happens is you have to do it fast. So like, the card is designed to be like, here's some data, and then the phone's like, okay, give me the next data. And if you don't give it the next data fast, it's like, oh, I'm done with you. So I think even if I could do this like perfectly fast, even the speed of the USB, getting the data from from my computer to the USRP, I think that would have been too much. So if you can do this, great. It was beyond what I could do. And then you could use Colin's memory injection one. That certainly would probably work. Some issues with that is that it's OS specific, so like it would only work at least now in Android. The other thing is the bugs that I'm going to talk about in a little bit. I think they're more like timing bugs. So it's not something you could probably do with memory injection so well. So there's some drawbacks to that method too. There's certainly drawbacks with my method as well, but I lived with that. So I did eventually, with the help of some people, and at the end I'll thank a bunch of people who made this possible, find a reader and some software that would I could do what's called card emulation, which means I could pretend I was a tag, or I could pretend I was another peer device. So the two combinations that work well is this ACR122U along with libNFC. So I could emulate type 2 and type 4 cards with that. And then with this other reader, this SCL3711, and then this software called NFCPY, I could do LLCP to a phone. So with that, I'm basically in business. I can start to emulate tags and put fuzz data in them and watch what happens. So with what I had at my disposal, I could fuzz the green parts of the protocol. So there's some tag types I couldn't do. If you could write software to do that. I just didn't do it, but it's possible. It's like physically possible. It's just I didn't do it. And then I can't get down to the radio waves because the hardware doesn't really support that. So anyway, I could fuzz like this. So there's still lots of stuff out there for people to fuzz that I didn't fuzz. So let's start with end-def fuzzing and how I did that. So this was really easy because there's software in libNFC that basically emulates a tag, and so I just create some crazy end-def data, send it to the program, and it emulates a tag, and everything's easy. And then to do the sort of lower memory type 2 fuzzing, back in this picture, remember, now instead of just fuzzing the data, I fuzz the higher level stuff. So the capability container, the serial number, anything like that. So then I can fuzz that by modifying the tools that come with libNFC. So then for type 4 fuzzing, remember there was this like file system. So now what I do is I fuzz this capability container file. Again, I just had to make some changes to the programs that were there already, so that I could write fuzz capability container files. And then it would just, again, it would read the capability container file, and then sometimes it would go on and read the end-def file. But I didn't really care about the end-def file at this part. And then for the LLCP fuzzing, again, I just modified things that were in the existing tool sets I had access to. So to where it would read in and fuzz, connect PDUs and fuzzed information PDUs and send them to the device. The only thing that was left was, okay, so I can emulate a tag, but how do I emulate like the setting the phone down on the tag and bringing it back up? And so it turns out that the way you can do that, in software, without people and stuff, is if you turn the NFC off and then set it on the tag, and then you turn the NFC on, the phone acts like the tag just showed up sort of magically. So what I do is I just turn that, by toggling the NFC on and off, it thinks tags are just sort of showing up. And it just happens that when the tags show up, they're different every time because I'm fuzzing it. And so there's this NFC service you can call in Android. You can turn it on and off with this command I give there, and then you'll actually see a little check mark, going away and coming back. And then there's for Migo, I just kill the service and restart it. All right, so this is basically the last element is that these readers weren't really meant to emulate like 10,000 tags in a row. So after like a little while, they sort of freeze up and won't work anymore. And there's nothing you can do like in software about it. The fix is you unplug it and plug it back in. A hard reset, right? And again, like I didn't want to build like although I did consider it, a robot that was just like, So what I did was I found this USB port or USB hub that you can control the power to with software, so I could like turn the power off on that port, and so it was kind of like I turned the device off. So anyway, and you can see like the water damage in my house in the basement in the background. Okay, and then so everything's cool. The only thing left is to check for crashes. In Android, that's easy. Logcat will show you whenever anything crashes. Migo, like I don't think anyone's really looked at Migo. It's sort of a obscure OS. So what I did there was I just used GDB and attached to the NFC daemon and looked for crashes that way. And then since I thought, well, maybe other stuff's going to be crashing besides the NFC daemon, I just did a PS and recorded all the PIDs of the processes. And then after I sent it, I checked to see that none of those PIDs changed or like no new processes showed up or went away or anything like that. And as you'll see, I actually didn't find any bugs in the low-level Migo stack, so I probably screwed that up. Okay, and then the other thing I did was like I would send a fuzzed tag to the phone, and then I would send a good tag and make sure that it showed up to make sure like I hadn't done something weird to the NFC service. And the way you do that is pretty easy. So in Android, tags, the default application for dealing with this stuff, it records it in a SQLite database. So you can just query the database and make sure that the good one showed up. Migo, if you turn on the NFC daemon with this extra logging option, then it just shows up in syslog. So you can just parse syslog and make sure the good NDEFs are showing up. So anyway, so then I had a fuzzer working. So these movies are entirely lame, but it took me 6 months to make this, so I have to show it. So this is the fuzzer running. So it's like, oh, that was a bad one. This is a good one. It can handle the good one. And then the bad one, it's like, oh, I can't read that tag. And then then this is the N9, and it's like, oh, here's a good one. So it's like boring, but again, like it was 9 months of my life or something, 6 months, I guess, to write the fuzzer. So then here is this one. This is a Nexus S. So then this is a good one, and then the bad one actually doesn't show up because it's so bad and evil. But then the next good one shows up, and it's you can even hear it dinging. It's very cool. So this is so like in my house, it would just be like bing, bing, like all night, and so like sometimes my kids, like I heard one of my kids would be like, hey, what's that noise? The other one was like, oh, it's just dad doing that fuzzing thing. So anyway, and then so there was this one of the readers actually was like, sometimes it would just go like super loud. And so that's why I was in the basement doing that fuzzing, because I was like, I can't even, like I tried like putting a pillow on it and stuff, but it was so loud I had to put it in the basement. All right. So what did I fuzz? So I didn't fuzz the latest and greatest. It was the latest and greatest when I started fuzzing, but it was a long time ago. Nexus S running 233 Gingerbread is what I did for Android, and Nokia N912 Har Matin PR12 is what I was fuzzing for the low-level Nokia stuff. And like you saw, it's pretty slow, right? So I did like around 50,000 for each one. Here's the test cases broken out as like low-level stuff for different types, LCP, which was the peer-to-peer, and then like tons and tons of NDEFs. Okay, so what did I find? I already gave away the punchline that on the Migo side I didn't find anything. On the Android side, I found some stuff. So it doesn't take long at all, like 10 test cases, and you'll start to see this. So tags like falls over real easy, but they're just Java exceptions, so it's not really security important, but at least you know that like it's working. And then if you fuzz a little more, instead of tags dying, pretty soon the NFC service will start dying. Again, if you look at the logs, you see here that it wasn't native code crashing, it was just a Java exception, so again, not so cool. Finally, then I started to find some native code crashes. One, this is just a no-point environment, so again, not so cool, but at least like it was just sort of verifying that my fuzzer was working and catching things and stuff. So if you send a connection complete PDU before you send a connect PDU, then it dies because there's a null pointer exception. Makes sense. but they should probably check that. And then here's one that's actually kind of cool. So so the important thing, I guess, is just to realize this statement, like LLCP, check LLCP, and then it dies in abort. So let's see what that one's all about. You can look at the source code and find that line. It's right here. So it's like up here it allocates something, and then like when something goes wrong, it goes in here and it frees that thing, and it jumps down to this guy. And down here it calls deinit, and then it frees it again. This is a classical double free, and this is again in the NFC daemon on like versions of Gingerbread on Android. So this is something that got fixed in Ice Cream Sandwich, and not by me. I didn't help them. They did it on their own. So that's cool. So the good news is if you run Ice Cream Sandwich, you don't have to worry about that bug. If you run Gingerbread, like apparently most people do, then you could still be vulnerable to that bug. And then I found a bunch of other crashes, and these are totally annoying. So I found these crashes. They're definitely look to me like memory corruption bugs. And no matter how many times I tried to replicate them, I couldn't. What would happen is if I ran like 1,000 test cases, I would always get more or less the same number of crashes that looked the same, but like I couldn't narrow it down to one. And my reasoning, and I tried like everything. So my reasoning is it must have something to do with timing. So, and it's really hard to replicate the timing. So anyway, but here's some crashes that may still be an Ice Cream Sandwich, or Jelly Bean or whatever, or may not. I have no idea. They're still kind of fun bugs. So here's one where it aborts in DL malloc, which usually means memory corruption. And again, these might all just be one bug, or they might be different bugs. Who knows? Here's one where it aborts in free. Here's one where it crashes in free, and you can actually trace back and see what happened. And it's trying to unlink a chunk, and the back pointer is like totally crazy. So and again, like that tells me it's probably memory corruption. And then there's another one that crashes in DL malloc. So anyway, so there's bugs out there. At least there were in 2.3.3. So and what these bugs would basically do is like if Todd Manning or someone had his phone in his pocket and I'm walking around with my hand by his phone, then I could conceivably get code execution inside of the NFC daemon. But keep in mind on Android, the NFC daemon does not have like internet permissions, but it does have Bluetooth permissions, which we'll see later is actually pretty cool. Okay, so that was the low-level code. Now let's look at the high-level code. And it turns out the high-level code, which I thought was going to take like 5% of my research time, was actually like the most exciting part of the project. So when you look at it, it's like, okay, so we've already basically looked at the NFC service and down. What over here besides tags, deals with data, doesn't require user interaction, and has bugs. So at first glance, when you look at NFC and the high-level apps, it's like totally boring. So this is Gingerbread on the left. It's like, text, right? It's going to be tough to find a bug there. In the middle, Ice Cream Sandwich, same. On the right is the connection dialogues on the Nokia M9. So it's like, it's going to be hard to find a bug if all it's doing is printing out like 20 characters or something. And that's the thing about NFC. It's like, well, NFC tags have like 200 bytes of data at most. It's going to be hard to find bugs, and I'm confident that a lot of software developers can write code to parse 200 bytes without making too many errors. But then they want to make NFC like really cool and exciting and fun and whatever. So they added all these features. So in Android, you can have like more than one NFC app. Besides tags, you can download NFC apps. Also, there's this Android Beam. And then they have these things for Nokia, content sharing and Bluetooth pairing. So we'll talk about each of those and if there's security significance. So multiple apps, not so exciting. It just means that you could imagine like, yeah, sure, tags is rock solid, but you download some other app from Google Play Store, and then you could exploit that or something. So Android Beam is something that that came out in Ice Cream Sandwich that would allow you like. You're jamming on your Ice Cream Sandwich device, and you want to like share a picture or something with your friend who has an Android device, and so you kind of like put the phones sort of close to each other and press a button, and it just like goes goes over NFC, and then they see what you're seeing. It's that's pretty cool, right? And the way now that you understand NFC, I can actually tell you how that works. And the way it works is uses LLCP because it's peers plus SNAP. And then if that doesn't work, then they use MPP. But the thing that's funny is when you're sending it, so it says like touch to beam, so the guy who's sending it has to press something, but the guy who receives it doesn't press anything, it just shows up. Which is, I don't know, it's kind of easy and convenient, but like here, you can actually share web pages, right? And I don't know if I want people pushing web pages to my phone. So you can see, and if you want to know which applications are set up for Android Beam, it's all done with intents like everything else in Android. So you can just go through all the Android manifest files and look for the ones that register the right intents. And if you do that for the version of Ice Cream Sandwich I looked at, the only ones are browser, the browser contacts, which is like your address book, and tags, of course. So it's actually the browser one that kind of freaks me out. So like here's the phone, right? You get near it with a tag, and all of a sudden it takes you to a website of its choosing, right? And the user didn't do anything. So I'm less confident that a developer can write a parser for HTML, MP3s, GIFs, JPEGs, fonts, videos, everything else, and not make a mistake than I am them writing something to parse NDEF, right? So for me, it's a little surprising that a phone can, with a tag that I can send you to a website. So here, finally, my assistants are going to show you like a pretty cool demo. So these two guys worked hard to make a cool demo for me. So let's see if it'll work. I have a video backup because I don't trust them though. So if you saw us scrambling there, that was because they were going to get here a half hour early so we could work on the demo, and they showed up 5 minutes before my talk. Let's see, make this bigger. Oops. Okay, so what's going to happen here is I have a Netcat listener. He has a phone with Ice Cream Sandwich 401, and then they have a tag as well, and so they're going to touch the tag, and then a shell is going to show up on the phone. Look at, see, he's just minding his own business on the phone. So let's see if anything happens. And then if you look at the phone, is there anything happening on the phone? Our internet might be down. Oh, like, what happened?
Let's do it again.
So then you're like, hey, like my browser showed up and then disappeared, but I'm going to just continue to talk on the phone as if nothing happened.
There you go, man.
Okay, so that time it actually worked. So now I have an interactive shell. So what is it? It's so hand for these guys. They wrote this exploit. It's really cool. So anyway, the takeaway is it's like touch a tag, get a shell, right? And it's sort of frightening. So this bug that they wrote the exploit for, it's a WebKit bug. It's the same WebKit bug they talked about in Steven's talk today, if you saw that. So it's not really an NFC bug, but still it's the fact that I can get a shell and all I did was get near your phone is like pretty awesome, I think. So anyway, great job on that. It was a lot of hard work. It's a cool exploit. So thanks a lot to those guys for that. And there's, okay. So up there's the backup video. We don't need that. We did it live. It only took 2 times. In the video, it only took 1 time, as far as you can tell. So sort of the takeaway from that is, initially you're like, okay, here's the attack service, right? It's like, a couple native code libraries, not much, mostly Java. This Java, tags application. But the real attack service is this, the browser, right? And so that's pretty screwed up. Okay, so what about Nokia? Like I've been picking on Android there, but it turns out Nokia's even in a worse position. So they have their thing. They don't call it Beam. They call it content sharing. And it's basically the same thing. It's like you put 2 N9s close to each other and you can share stuff. And again, without user interaction. And so on Android, there's a setting for NFC on/off, and that's it. You got no other choices. On N9s, you get a second setting that you can choose. So it's called confirm sharing and connecting. So it's like, well, that sounds secure. But the thing is, even if you have that on, I can still push files to your phone and without you doing anything. So we'll talk about what that actually does later, and it's actually a good setting that you should have on. So here's an example of like what I'm talking about. So if you notice, so this is an N9. Bluetooth is turned off because like only crazy people would run Bluetooth, right? So I get it near another device. And you can see like, oh look, Bluetooth's on now. What happened? I didn't touch anything. Oh wait, it's downloading something. Well, it can download files. I don't care about that. But it's just download. Oh shit, it's rendering it too. But it's probably just like an image or something, so it's okay. It'll take a while because N9s are very slow. But it's like, yeah, it's a JPEG or something. It's like, oh crap, it's a PowerPoint. No one can write a PowerPoint parser properly. So the attack surface goes from this NDEF parser to almost everything. So you can't do the browser on the N9, but you can do basically everything else. So like all the image formats, video formats, audio formats, and then the thing that's super frightening is the Office suite. So like PDFs, Word documents, Excel spreadsheets, and stuff like that. And again, there's nothing you can do if NFC's on there. That setting that sounds secure doesn't actually help you. And having Bluetooth off, which is the way they actually transfer the file, doesn't help you either. Because this turns on Bluetooth for you. But it is convenient. So here's again, this is what you think the attack surface is, but the real attack surface is this. Okay, so then I want to actually write an exploit. Say I want to own Travis Goodspeed. I understand he has an N9, so I want to own his phone and steal all his stuff. So what do you do? Well, the latest N9, which is 1.3, it ships with vulnerable versions of software. So one you can look at is libpng. So it comes with 1.2.4.2. But if you go to the libpng website, you'll see there's at least 2 critical warnings for that. So you could write a libpng bug. You get near the person, it ships over PNG, and you own them. But if for me, like using a public bug is like so passe. I want to find my 0 days, right? So I fuzzed for like a couple days, some of their high-level apps to see what I could find. So I found this like PowerPoint bug. It frees some random pointer. This PDF bug that is it lets you write stuff. But the best bug I found, and I just found it like last week because I was bored, is this bug. So this is a bug that's in the way they process Word documents, and it's also in KOffice too. So it's a KOffice 0 day if anyone uses that product. In Linux, I doubt there's like probably 3 people in the world I could totally own with this. But so the way it works is there's it's reading in a Word document, and it does an allocation here based on some number that you've given a long time ago, and then it reads in another short here, and then it starts copying that number of bytes from the data stream into this buffer that was allocated with some other thing. So it's a classic heap overflow. You control the length of the allocation, the length of the data that's getting copied and the contents. So it's sort of the easiest one you can imagine. And if you still don't believe me that I could have exploited it, but I ran out of time. Here's the file I wrote. So here's the length, and then here's the data. So it crashes in some random place that it didn't know where that was. One thing I gotta say is like the tool chain on N9 is way better than the tool chain on Android. So get your act together, Google. But anyway, so it crashed. If you go in the backtrace, it crashes here. And why did it crash? Well, it loaded from R3, something into R12, and then it branched to R12. And what was R3? Well, I controlled that. So I could have gotten control of program counter with 5 more minutes of effort. So there's your 0 day for the N9. So that's what you can do no matter. Oops, hold on a second. I don't want to show you that yet. So that's what you can do. Pause. That's what you can do no matter what they did. But suppose then that they didn't change that secure setting of inform me. So if you don't flip that on, which is by default it's off, then you can do this Bluetooth pairing, which is really crazy. So if you Google Nokia N9 NFC, all you'll see is like 1,000 versions of this video. So it's like dude is like jamming to his music, and then I went and I bought this speaker. It's right here. I can show it to you. It's pretty cool. So he touches the phone to the speaker, and the speaker starts playing your music, and he didn't touch a key, right? It's like, how the hell does that happen? So I bought a speaker, and my N9's broken, so I can't show you exactly, but I'll show you like that it works on Android too. So let's see, how do I play music? See, I only use my phone for hacking purposes, not for enjoyment. So like here it's playing music. You probably can't hear it, right? But like you just set it near here, and it's like, so and then it just like starts playing on the speaker. I don't know if you can still hear it, but It's like, how did that happen? And I thought, I must have turned off something because I think on Android usually it throws up a dialog, but the thing is on N9 it doesn't. And got it. So let's see what you can do with that. So how does it work? If you dig in and you figure out what the hell's going on, it turns out that there's a particular NFC NDEF message that then allows you to pair with Bluetooth pair with a device. Again, this only works if you use the if you haven't turned on this extra setting. So this is what the NDEF message looks like. You give it Bluetooth address to pair with, a PIN, and the name of the device. So like my whole life, I wanted root shells, right, for me. But it turns out that what I really wanted was this. This is actually better than root shells. So like it's hard to write exploits, but it's easy to pair, it turns out. So here's a video I made because I didn't want to do it live. So here's a phone, Bluetooth is off, right? I touch a tag, there's my tag. I touch it to it. It just dings, and then that's it, right? So there's nothing going on the phone. Now over on my computer, so what's secretly happening underneath is that it's paired with my computer. If you look up here in a second, you'll see, I'm trying to so up here it's like, you are now paired with the N9. Awesome. So the user didn't do anything. So now I can do things like, mount the N9's file system to my computer and, read all the files. So there's like the files on my thing. And meanwhile on the phone, there's like nothing going on. If you notice, like if you were like a genius, you would have noticed the little blue light that says like Bluetooth is on. But if otherwise, there's no indication. So then you can see like, oh wow, the sound's on. So you can see like, here's the pictures that people have taken with their camera. Here's pictures that you downloaded. Here's your music that you like. You can just download this stuff if you want. Here's like, Word documents. So you can access all the files in the file system. And I didn't have to write like ASR bypass exploit. I just had to run that tool. Okay, so then you can also do things like, besides reading files, you can do things like sending a text message. So here I am sending a text message to my phone, and it shows up on my phone. So there's me sending the text message to me. Anyway, so you can send text messages. Then you can read all the files. You can access all the contacts they have. So all the people they have in their phone book. That includes the ones that are stored sort of on the file system and also the stored on the SIM card. So you can see here in a second. Movie's almost over, I think. So here's all the contacts that the person has. And then like the coolest thing is then you can actually make phone calls too. So here I am making a phone call, and I'm trying to be very subtle so that you all don't secretly find out my phone number. Haha, you'll never know my phone number. And then you actually see something going on here that you see that the phone's dialing. And then on this side, you see that the phone's really dialing. So anyway, you can get complete control of the Nokia N9 with an NFC tag as long as they don't have the paranoid setting set with like they say, no tools at all. But if they have that, if they're paranoid and they flip that switch, then you can get them with the Word document parsing bug. So no matter what, they're screwed. So this is what it looks like if you try to do the pairing attack and you have that setting switch. It's like, do you want them to connect? And then you can just hit no, and nothing bad happens. Okay, so that's basically it. So in summary, so NFC. Hey, look, someone's calling me. So NFC opens up like a whole new sort of attack server side. NFC attack stacks are like really hard to test, which is why I wrote code to do it, and now you guys can do it too. The biggest takeaway is like before you push a web page or something to me, like for God's sakes, give me the option to say no. And that's basically it. So here's the code if you want to download all the code. Tiny URL NFC files. And then lots of people I have to thank for this. It's way out of my comfort zone. So it was partially funded by Cyber Fast Strike. These two guys were awesome. A lot of other people helped me out. That's it. Thanks.